Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
Hello, everyone. Welcome back to the Everything Building Envelope podcast. I'm Paul Beers, CEO of GCI Consultants, and I'll be the host today. I'm excited to do this podcast. It's probably been over a year and a half since I last did one. I've been super busy working on hurricane claims. As you know, there was a lot of hurricanes in 2017, 2018, and we've been scrambling ever since to help folks identify and remedy the damages. I'm really excited today to have as our guest returning Jason Bondurant. Jason's a senior consultant here at GCI Consultants. So we have a really interesting topic to share with you today, which is all about water leakage investigations. So Jason, welcome.
Thanks for having me.
Probably have people that listened the last time you were on and maybe some that didn't. So you just tell them briefly a little bit about yourself, and then we'll hop right into the topic.
So I'm a senior consultant for GCI. I've been working for GCI for about 6 years. Right now I'm dealing mostly with problems with existing buildings, doing forensic investigations, something that I really enjoy doing, and I look forward to talking about it with everyone today.
Great. So I think the underlying factor here with obviously talking about water leakage investigations is the problem of water getting into buildings and water damage. So Jason, could you maybe just talk a little bit more about what goes on when water starts coming into a building and causes the damages?
Yeah, well, and I'll just say to start off that, when we're talking about forensic investigations of buildings, the majority of the cases that we deal with are water intrusion problems. Water damage is the biggest source of insurance claims, and it's something it's a really big issue for us, especially in South Florida here, where we have, extreme weather conditions. So water damage is a big problem. It causes damage inside of buildings. It's difficult to accurately trace and resolve. And it's something that I think most building owners, property managers, architects, contractors have experience with.
Yeah, so it's funny because I always say, how do you have a big problem with the building? Have water start coming into it. It's just nothing good happens. People get upset. There can be health issues, it damages interior finishes, things like that. And what's really interesting, Jason, and I know that you've been involved in all these areas, is that any type of building can be affected by water damage from a newly constructed building or even a building under construction to, which is construction defects, things like that, to existing buildings that maybe have had problems all along, or maybe over time with maintenance issues and whatnot, problems develop, and then of course storm damage. So you've worked on a lot of different scenarios where you have water problems, haven't you?
Yeah, we get involved in all those types of situations, and one thing that I will say is that every single one is unique. There's not a single one that is exactly the same. They all have to be assessed and evaluated uniquely according to, the conditions on that specific project. But, absolutely, we deal with condominiums, hospitals, office buildings, single-family homes. Water damage affects all of them.
It's a big problem. So I thought what we might do is lay a little foundation for, and let's focus on windows and doors today, as opposed to, that water damage can occur in many areas from below grade, underground, right on up to the roof. But there's a lot of stuff to talk about there. We could do many podcasts, but for right now, let's just focus on windows and doors. So let's lay a little foundation for what some of the standards are for windows and doors, and then we can talk more about how to investigate specific problems. So Jason, what is the criteria for new window and door assemblies to basically get certified for use in building codes nationally and regionally?
Well, any window or door product has to go through a slew of laboratory tests in order to get approval. And basically, tests involve structural tests, water infiltration tests, air infiltration tests, impact resistance tests, which are especially important here in South Florida, forced entry resistance tests, so on and so forth. The important point here, in this podcast dealing with water intrusion is that there's a big difference between how the products are tested and what the design rating is of the products from a structural standpoint versus a water intrusion standpoint. So typically when the products are tested in the lab from a structural standpoint, they're tested as much as 150% of the design rating of that window or door. So if that window or door is rated for 100 PSF, it was tested in a lab for up to 150, just as an example. Now, when it comes to water, the bar is set much lower, and we could talk about why that is, but as of right now, and we could talk about whether we think that's adequate or not, but as of right now, the requirement for the testing for water infiltration resistance is only 15% of the design pressure rating of the window or door. So just think about that for a second. So structural, 150%, water, 15%. There's a big difference there, and it's somewhat justified. I mean, structural is more of, a life safety issue, so it's understandable. But the point is that if you have, and we deal with a lot of building owners that have this misconception, they think that their window or door is rated for 100-mile-an-hour winds. Well, that may be true from a structural standpoint. It's not necessarily true from a water intrusion standpoint.
So when these things, and then on top of that, when these things are tested in the laboratory, how would you compare the laboratory conditions to field conditions?
Well, obviously, a lab it's a very, so the way that they test these things for a water test, for example, is in a lab, it's typically a 15-minute test. And as we all know, especially being here in South Florida, we get rains that last a lot longer than 15 minutes. So it's not necessarily simulating all different types of natural conditions that can occur. So it has its limitations. It's designed that way for a reason. But you can't compare these lab tests to the conditions that the window or door would experience during tropical storms or hurricanes.
Yeah, so the thing that we've seen here in the last year or two in Florida and other areas actually is that you have the 15-minute lab test to certify the products for building code approval. When Hurricane Irma hit South Florida, they were basically under high loads and heavy rain for 8, 10, 12 hours or longer. So the duration of the real storm, and that can happen not only in a tropical storm, even in a low pressure system, whatever. The duration of the time that windows and doors are subjected to wind-driven rain in the field can vary greatly from a laboratory test. So let's kind of just go through this. So we've talked about what they do in a laboratory. Then we go out and we install these windows in a building. Let's say it's a high-rise oceanfront building somewhere, Florida or Northeast or wherever. So how do you, when you install a new window, Jason, how do you know, how can you give yourself assurance that that it's not gonna leak once the building is occupied?
Well, so GCI also gets involved in quality control for new construction projects as well. And typically what we would do on these kinds of projects when you have a newly installed window or door into a building, there is a test, a field test for testing the water infiltration resistance of windows and doors. And it's very similar to the lab test. Basically, we're spraying the exterior of the window or door with a spray rack that's uniformly spraying water over the surface area of the window or door. And then on the inside, there's an interior chamber that's mounted to the window or door, and that's done in order to apply a pressure inside in order to simulate a wind-driven rain. So you're basically sucking water into the window or door during the test. And it's very similar to the lab test. The only difference is that the field test is performed at 2/3 of what the lab test was performed at. And the reason why it's done that way is just to account for imperfect conditions in the field. So they allow a 1/3 reduction factor. But again, it's still a 15-minute test, and this is the appropriate test. This is the test that architects are specifying for quality control on new construction projects.
So just to take it through the numbers again with our 100 pounds per square foot rated door, can you just run through the structural test pressure, the laboratory test pressure, and now the field test pressure, just so people can get a feeling for, what we're looking at?
Yeah, so if it's rated for 100, then the maximum load that it was tested at for from a structural performance perspective was 150% of that, or 150, and the laboratory test for water infiltration resistance is done at 15% of that, or 15 PSF, and the field test would reduce that lab test pressure by 1/3, which would be 10 PSF for the field test.
Yeah, so I'm going to just say that reducing it to 2/3 is not my favorite thing to do. It's an industry standard, and I understand, but architects and specifiers are also free to, write their own field test specification. And my recommendation is to test it at the laboratory pressure. If it's a brand new window, just gives you a higher margin for error. Manufacturers, contractors, whatnot, installers may not like it, but it does raise the bar a little bit.
And just maybe put this in terms that people would maybe understand a little bit better than pressure. So if we're going to do a rough approximation between the pounds per square foot and the wind speed, if you're talking about 100 PSF, you're talking about almost 200 miles an hour. If you're talking about, so that's from a structural standpoint, and we sometimes see this in marketing of the window and door products, that they say it's rated up to 150 miles an hour. It comes from that, but when you look at the 10 PSF, you're talking about around just over 60 mile an hour winds. So and actually that's even quite high. I think it's normal for us here in South Florida. In other parts of the country, that's very high, and most products are not rated that high. So that kind of puts it into perspective for everyone.
And, the 60 mile an hour wind speed, if we'll just use that as an example, pretty much will take care of everyday weather conditions. Even when you get a microburst, a wind-driven, thunderstorm, summer thunderstorm, things like that. It's when you get into these extreme weather events like hurricanes that it exceeds the rating, and stuff will leak that's not rated that high. And
we would expect it to leak. Yeah.
Yeah. Okay, so now we've talked about something that's newly installed, and that's how it gets tested. So now let's talk about, further down the road. So what the industry standards say is that the field testing of a newly installed window or door assembly should be done within 6 months of installation, which is interesting because some projects, they're in place for longer than 6 months, even before the building's finished on a large high-rise building. But So if leakage occurs later than that, say it occurs 5 years later, what has to happen then, Jason?
Well, so if we're talking about down the road, I think more often than not, the reason why the testing is even happening in the first place is most likely because there's some kind of a problem. There's some kind of a leak. So what AMA, who is the governing body for all these different test standards for window and door products, what they say is that you should use AMA 511, which is the guideline for forensic water penetration testing of fenestration products. So basically, what you're trying to do with AMA 511 is it's more of a diagnostic procedure as opposed to a quality assurance one. So you're trying to determine where that water is coming from under, normal service conditions of the building. So AMA 511 directs you to another standard, which is ASTM 2128, which is the standard we use for evaluating water leakage in building walls. And these two standards together are what kind of guide us through this type of leakage investigation. And so, I think we should probably start from the beginning. Before we even get to the testing on these types of projects, there's other things that need to happen. It's basically a whole systematic approach to investigating the water leakage.
So let's take a deeper dive into ASTM E2128, which is called, what is it called, Jason?
Evaluating water leakage in building walls.
Yeah. Let's go through all the steps of a water leakage investigation. I guess the first question I would have for you is it just water testing or is there more to it?
No. So, when we get called into these kinds of projects, it's usually an existing building. Maybe it's been constructed and in service for 30 years, 40 years, even longer, sometimes new buildings.
Let's take a deeper dive into ASTM E2128, which, and the title of the document, by the way, is Standard Guide for Evaluating Water Leakage in Building Walls. And the document basically outlines 8 steps in the process for what you would do to investigate water leakage in building walls. And I'll run through the list, Jason, then maybe we'll go back in and talk about them. So the first thing they say you should do is a review of the project documents. Then, number 2, evaluate the design concept, in this case of the windows and doors, which we're talking about. The next thing is a determination of service history, then an inspection, obviously a site inspection, then investigative testing. We're going to talk about that, I'm sure, more. We've already talked about it somewhat. An analysis of the results, and lastly, the production of a report. So, Jason, the stuff that we do before we go out and do the inspection and we do the investigative testing, let's talk about that a little bit. And I want you to also focus on what happens if sometimes some of this information isn't available. How do you go through, trying to figure out what we've got and how to work with it?
So typically when we get involved in these kinds of things, usually it's a building owner that comes to us and says, we need your help. We have a leak in, unit whatever, or we have leaks all over the building, and we need you to come and tell us how to fix it. And there's very little information that's provided up front. So the first step that we always do in these kinds of things is we try to gather as many relevant documents as we can that would help us in our investigation. So usually what we ask for are things like construction drawings. If we're dealing with windows or doors, we would try to see if we can get shop drawings, if we can get any information about what the types of products are, if there's any leak logs, anything, maybe a maintenance book, something where they're recording when the leaks have happened. I would say that, this step, it varies widely between different buildings. It mainly comes down to, I think, the property manager and how good a job they've done of collecting and retaining all of this information over the years. Sometimes we get almost nothing, and sometimes we get a lot of stuff. And this is the type of stuff that can really help expedite our investigation, if we have a lot of this information to build on. So once we've gathered all of that information, then according to ASTM 2128, the next thing that they say needs to happen is you need to evaluate the design concept. And what they're really referring to there is, how is the envelope of the building, how was it intended to manage water? If you're talking about a wall system, is it a drainable rain screen type of wall system where you have a weather barrier behind the exterior cladding? Is it a barrier wall system, which is more typical for us in South Florida? Also evaluating the design concept of the windows and doors themselves. We just want to understand, what was the intent of the design. The step after that is determining the service history, which we're trying to find any information about, like I mentioned before, if there are any leak logs that say when and where leaks have happened. That information is really useful. If we can get any information about prior renovations or remediation attempts, a lot of times when we get involved in these kinds of things, we are probably not the first, maybe not even the second, but maybe the third or fourth person that's been called in to help them determine how to fix this problem. I mean, typically most owners are going to contact a contractor first if they have a problem. And generally when we get involved, it's when someone has tried and failed to fix the problem. So we want to know what were the prior repair attempts. And so all this is done really before we even really start any field work on the project.
Yeah, so it's interesting that a lot of times when we do get involved, there's been various types of attempts to stop a leak. And it's hard, and we get these calls every week, where things have been done, money's been spent, contractors have done things, installers, whatever, and it's still leaking. And that's why this systematic approach to evaluating water leakage using this ASTM standard with some AMA guidelines about how to use it really is a great way to go, because it's a scientific way to evaluate the problem and to determine what the fix is, and then you can even verify it with further testing that the fix worked. And Jason, this is there's never any guarantees for success, but can you talk a little bit about, I know you're humble, but can you talk a little bit about how much luck we have had with this?
Well, and you just made me think of one other thing, and just to give you one quick example about what we were just talking about. So part of the reason why when you're going through all this stuff is you need to evaluate the design concept. And a good example of that is, a lot of times we'll come and we'll see that there were past remediation attempts on a particular project. And in some cases, the remediation attempts have even made the problem worse, because whoever either designed or performed those repairs did not evaluate the design concept. Just as an example, if you have like a drainable wall system, like a weather barrier behind the stucco as an example, that's typically designed to drain out at the head of a window or door, and it does that by having a through wall flashing at the head of the door, where the weather barrier laps over and directs the water out and prevents the water from collecting on top of the head of the window. Well, we've been involved in several of these where maybe the contractor comes out and he sees that opening there, doesn't really understand what that's for, seals it up, and now they've just made the problem worse. So not only did they not fix the problem, they've made it worse. So that's just one example, and why it's really why, like you mentioned, ASTM 2128 is laid out that way, so that you don't make those kinds of mistakes. And just to answer your question, I mean, I think we have a pretty good record for fixing these things. I will admit that some of these are incredibly challenging, and we're not always going to have all the answers after our first time walking on a project and looking at some of these conditions. And I think we're about to get into the testing aspect, but I think in the end, we're going to go through the process, and I think we've been very successful as long as we stick to this general methodology.
The word that I was thinking, and when I think of you, this is a word I think of, is tenacious. I mean, you've got to sometimes dig deeper and deeper and deeper. And I know you've literally done this in like areas where you've got leakage of say a basement or something. You have to dig all the dirt out just to get there to look at it. But it's sort of the same thing with windows and doors. And this is a nice segue for us to talk about what we do as we start getting into the investigation. So again, maybe we're not even ready to test yet. What do we do when we go out to the site? How does that process work as far as figuring out what we've got and what we need to do?
So when we go out to the site, one of the first things I like to do, and this is part of the determination of service history aspect of it, but you want to interview as many people as you can that do have information about the in-service performance of the building. So usually managers, building engineers, maintenance people, owners. We like to talk to them and have them show us where the problems are, get an idea when or where the problems occurred. So that's one of the biggest things we do when we first go out to a project. And then the other thing we do is, obviously, we're there to perform our initial visual inspection. And, when we do that, we want to look at, usually how I like to handle it is I like to go inside the building first and see what the evidence is of the leak, just to get an idea of, where the water damage is occurring, and maybe start to get some theories about where it could be coming from on the exterior. Then we would go to the exterior and just visually look and see, is there any obvious things that we can point out right away that, we think could be suspect. So now we're really starting to maybe focus on certain aspects where we think we really need to dig deeper on. And so that's really the first visual inspection part. And then the other thing that I like to do is typically, when we do these, there is going to be some amount of testing that's required. So while we're there for that initial visit, we're already thinking about, okay, these, like I mentioned, we're developing a theory, and we're starting to think about in what ways can we perform some kind of forensic diagnostic water test in order to help verify or disprove that theory.
So now we've looked at the damage. We've looked inside and outside at any, for any obvious defects or errors, and we've elected, which we normally do, not every time, but many times, we then elect to do investigative testing. So how does that work?
Yeah, and I would say most of the time we do the testing. It's really important. And the first thing I'll say, I guess right off the bat, and this is something that a lot of people don't totally understand, is that the testing, a lot of times on these cases, if you're dealing with water leakage problems on a huge building and the problems are very widespread, it's not realistic to go and test every single location. But some amount of testing should be done, and I think it's very important. So, what we try to do is we come up with a really detailed plan for what we want to test. What we're trying to do with the testing, just as a big picture, is we're trying to recreate leaks that would cause observable damage that we're seeing inside the building, and we're trying to do it in a controlled way where we're isolating different aspects of the building envelope at a time. So, in other words, and I always tell people this, but I could go to a building that has leak problems when it's raining, and I can see leaks coming in, but it's not really going to tell me that much because the whole wall and windows and the roof and everything's getting wet outside. So, as most people know that have dealt with these types of problems, water can work in sometimes seemingly mysterious ways, and it's difficult to be able to pinpoint exactly where it's coming from just by looking at it. So we're trying to isolate different things. So, and we're trying to, verify a hypothesis. So prior to the testing, we've already gone and we've inspected the building, and, we've seen, I think we're starting to see what the patterns are. Are we seeing water damage mostly at the head of the window? Are we seeing it mostly at the base of the wall? Are we seeing it, at multiple different types of conditions? So we're starting to try to see what are the patterns there, and then we want to test some of these typical conditions. So we want to select locations that are representative of what we've seen from our visual inspection and come up with a specific protocol for how we want to do the testing. It takes a lot of coordination. Typically, we're working inside of someone's unit, or we might be working inside of a hospital or a government building, and the testing itself can be sometimes pretty disruptive if we're doing destructive testing, which is also a part of our investigation occasionally. That is obviously destructive. And so it is an interruption to the building's activities, and it's something that has to be carefully planned and organized between us, the property manager, the owners, anybody else that's involved in the project.
I was going to say, tell us a little bit more. When we used to say destructive, that's a scary word. And I know nobody likes to hear that. And I don't think we like to say it, but it's a necessary evil. Can you talk a little bit more about just maybe an example of what we would do that's destructive and why we would do it?
Well, I would say that we don't always do destructive testing. This is something that we determine on a case-by-case basis. But the reason why it is sometimes necessary, to state the obvious, we don't have X-ray vision. A lot of times people think we can use things like, infrared cameras, and we do, and that's a useful tool, but still we can't see through walls, So if you're dealing with a wall system, as an example, like I've already mentioned, that has a weather barrier behind the exterior wall cladding, like stucco, typically what we would do is we would do our water testing first before we modify or destroy anything, obviously. But, if we're able to recreate a leak in a certain area, the fact is with that kind of a wall system, as an example, we're not able to see the actual weather barrier, the actual component on the wall that's resisting the water, and where, the failure most likely is occurring if the leak is there. So we would need to actually remove the stucco there if we're in order to see what the problem is. Now, for South Florida, most buildings do not have that type of wall construction. They're mostly barrier wall systems, concrete and CMU, and direct applied stucco, which are designed to just deflect all the water at the exterior face of the wall. So in that case, the destructive testing is probably not necessary on the wall system. Where we usually, well, not usually, but where we sometimes may have to do it, at least when we're investigating wall and window leak problems in South Florida, is we may have to remove interior finishes, usually around a window or door, in order to see, because what can happen is you could have water that could get in behind drywall at the interior, and it can run down. It can enter through the building envelope higher up on the building and then run down within interior finishes where you can't see it, and you may only be seeing it at the bottom of the wall when it's really getting in at the top. So that's typically, if we're doing anything destructive on leak investigations in South Florida dealing with doors and windows and walls, it would typically just be that, just removal of interior finishes. And sometimes if it is just removal of interior finishes, that step would actually be done prior to the water testing, just because we want to be able to actually see inside better while the test is going on. But that's something that we determine on a case-by-case basis, and we would only ever do anything destructive if we had really good justification and reason to believe that there was a problem there. We're not just going to go into a unit and say all the drywall has to be taken out because we're not sure. No, we're gonna pinpoint it as best as we can to a general area, and we're gonna focus on that only if it's absolutely necessary and we feel like we can really justify having to do that destructive step.
Because if you didn't do that, you may have incomplete results, or maybe things going on that you couldn't see. So, and just to set people's mind at ease, we're talking about cutting their drywall. How do we handle that so that when the evaluation's over and the problem's been solved and all that, how do we handle removing drywall on someone's unit and then getting it back to like we were never there before?
Well, like I mentioned, these things, I think the important thing is we need to have a good plan for what exactly we want to do ahead of time. And as part of that plan, depending on what needs to be removed and replaced, if we were in that type of a situation, we would probably involve a contractor who would be able to assist us with the testing and be able to cut things open and then be able to immediately follow behind us and close things back up, at least temporarily, so we can return the unit or that space back over to the owner.
Yeah, because the other thing that thought of when we were just talking about this is a lot of times the window treatments need to be removed, and that's sometimes easier said than done. But a good contractor can remove and protect the window treatments, can in a neat way open up any areas around the window with the drywall and paint, and then put it back and restore it and repaint it and make it look like we were never there. So it's not something, unfortunately, sometimes that's just a necessary thing that needs to be done, and not doing it might get an incomplete result, which obviously nobody wants. We're there to solve the problem. You had mentioned that, if you had a building where water leakage is occurring all over the building, that you wouldn't test every window, you would only pick certain areas to test. So the question that's often asked is, well, if you're not testing every window, how do you know in the end you're not going to fix everything, or whether we're going to be able to successfully fix everything?
Yeah, and I think the amount of testing we do is going to depend on the amount of different conditions that we're seeing and the amount of different things that we feel like we would need to test. So this really is something that is determined on a case-by-case basis. I think some people think they have in their mind that you need to do 25% or you need to do 50%, and these are just basically pulling numbers out of thin air. There's nothing to really support that. And it's important to keep in mind that there have been people that have talked about the statistical significance of these kinds of things, and I think we have to be realistic when we're evaluating these problems. And like I mentioned, if we're dealing with, just to give you an example, if we're dealing with a problem at a building, and let's say we surveyed 100% of the units in the building, visually went in and looked at 100% of the units, and let's say that 50% of the units that we went in, we saw evidence of water leaks at the windowsills. We didn't see anything else. That was it. And they all pretty much looked about the same. Maybe some of them were a little worse than others, could be depending on what the exposure is on the outside of the building. But let's say that the evidence of water intrusion was pretty much the same, and every single one that we saw was leaking. Is it really necessary to test every single one to be able to show that they're all leaking the same way? I think, if you, in that example, you pick a few that are representative. Maybe you pick a couple on the east side of the building, a couple on the west side, a couple at higher floors, whatever the case may be, and you test your theory. And I think it's not hard, it's not a big leap to understand that it's most likely the same problem that's occurring on other units that have similar evidence of water damage.
So what you're talking about, which is what the ASTM E2128 is based upon, is a qualitative analysis. So if you look at every unit in the building, that's a quantitative analysis. Quantitative is, the number of units you're going to look at is 100%. A qualitative analysis is where, in the case of ASTM 2128, is where you would find areas with known prior leakage and you would investigate them. And as you said, of the typical conditions, and maybe there's one, maybe there's more than one, and then you can use expert judgment to apply those results to the remainder of the project.
Right. I feel like we skipped over the water testing part a little bit, and we should just mention at the beginning, when we're doing the water testing, we're trying to isolate different parts of the exterior envelope at the building at a time in order to pinpoint where that water is coming from. And I think, we began this whole conversation talking about what windows and doors were rated for, what they were lab tested for, what they were field tested for new construction. And I think it's important to point out that, like we mentioned earlier, the test standard for the forensic water testing of windows and doors is AMA 511. And the important thing that we have to talk about, and we see a lot of people make this mistake, is that it's not appropriate to test windows and doors to their original design pressure after they're more than 6 months old, according to AMA. And, we can take an extreme example and say, there's a 20-year-old window on a building. It's not logical to go and say we're going to test it according to its original design. It's 20 years old. It doesn't make sense. And not to mention that the fact that original design pressure, that window never even experiences those conditions normally at this particular location. So, if we decide that it's necessary to do a chamber test to simulate a wind-driven rain condition on a window or door, how we determine that test pressure according to AMA 511 is based on local weather conditions. So what they tell you to do is, ideally you would know when exactly the window or door was reported to be leaking, and you could look up what the weather conditions were on that day, and you can do that on NOAA. There's various websites you can find that information going back years, even if you wanted to, and you would test it to simulate the wind on that day. So let's say on that day you look up the weather and it said they got a half an inch of rain and there were 30-mile-an-hour winds. Well, you're going to do the chamber test to try to simulate those 30-mile-an-hour winds, which is, at least in South Florida, often much, much less than what the window was originally designed for. But, and I can't stress this enough because we see other experts in our field that also make this mistake all the time. And you should not be testing these older windows and doors to their original design pressure. Now, it could be that the leak only occurred at much higher wind speeds. So it's certainly plausible that something leaked only because the conditions exceeded what it was rated for. But, there should be weather data that supports that and the whole thing. But we're trying to simulate conditions that actually occurred at the building.
So the point here being that you're not necessarily trying to make things leak when you do these tests. You're actually trying to use the tests as an evaluation tool under real world conditions to find out what's going on, figure out how to fix it, and then and confirm that the fix works.
Well, and I think you're trying to recreate a leak. You're not trying to make a leak. You're not trying to make things leak that have never leaked under normal conditions. But if you can recreate a leak that looks like it could have caused damage inside the building and do that in a controlled way, like I mentioned, by isolating different things, then I think that tells you a lot. And that's really what we're trying to get at with the testing.
Yeah. So let's real briefly talk about what a leak is, because it sounds so simple. Water coming in the building, it's leaking. There's industry standards around leaks, and leaks can be interpreted differently by different people. And the thing that comes to mind when I think about this is that when you have a sliding glass door going out on a balcony and it rains, what happens inside the sliding glass door track, Jason?
Well, right, and this is something we get comments on all the time. But most sliding glass doors in South Florida, they have a drainable sill member, which is designed to collect water that meets the door and drain it back out to the exterior.
So you can, during a rainstorm, the homeowner could be looking into the track and it could be full of water and maybe not understand that and think that they've got a problem when in fact it's performing the way it was intended to.
Yeah, and this is going back to evaluating the design concept like we talked about, and I've seen cases, buildings in South Florida where we've had, maybe it was a maintenance guy or somebody went and they saw water was getting into the track and they felt like it shouldn't be there, and they apply caulking to the inside of the track, like between the fixed panel and the sill, and not really understanding what they're doing. Now they're actually reducing the ability of that sill to drain water, and now they have water that's overflowing inside of the unit over the sill. So they've just, again, by not understanding the design concept, you've just made it worse.
Yeah.
And we do see that all the time.
So let's just talk about, some of the do's and don'ts with the water leakage investigation. So Jason, that's really interesting. I don't think people realize the complexity of water leakage investigations, but and to do them correctly. And as you said before, we see so many times when we go out and there may be, people that are working for the property, contractors, design professionals, whatever, that don't really understand this and they don't do it correctly. And ultimately, unfortunately, the problems don't get solved. So I've got a list of do's and don'ts that I wanted to run through in closing. So do select test assemblies based upon the service history and known water leakage occurrences. So you want to test in areas where leakage has occurred before, and you don't want to randomly select test locations. This does bring to mind a project that we just recently worked on, Jason, around a hurricane claim, where we did exactly that. We tested assemblies based upon where we saw evidence of ongoing water leakage and water damage. And what we did after that was we actually tested some assemblies where we didn't see evidence of water leakage, but it wasn't random. It was done purposefully. And the reason was twofold. One was that all the windows and doors in this building got hit with extreme winds over 100 miles an hour, rain, long duration of time. And we wanted to, we suspected there may have been concealed damage inside the assemblies with sealants and weather strippings and things like that you could only see if you took the whole thing all apart. And we wanted to basically verify if there was water leakage occurring as a result of concealed damage. The second thing that we wanted to evaluate was this building was, I can't remember, 30, 40-year-old building. And many units had the original 30, 40-year-old windows in them. Other ones had windows that were replaced before the storm that may have only been 2 years old, 5 years old, 10 years old. We wanted to test some of them also to evaluate how they perform in everyday weather conditions. So there's a lot of latitude to the investigator using ASTME 2128. And in this case, to do a thorough investigation, we expanded the sampling to cover that. Another thing you just got done talking about was do carefully follow the professional standard of care in determining test pressures. You want to get appropriate test pressures to simulate real weather conditions that have occurred at or near the site. Don't test to cause leaks. You don't want to just test away and have everything leak, because you've really proven nothing except that you can make them leak with your test equipment. Another thing that you touched on, Jason, was do isolate test areas to conclusively document water leakage sources. That's where we might, for instance, put tape and plastic over the caulking and the stucco that surround the window and door, so that the water only goes on the window and door, and that way you can basically see how the window and door by itself is performing. And you could do it the other way around. And sometimes we do it both ways, where you can isolate the window and test the stucco. So there's a nice little list of do's and don'ts. Jason, really great job. Really interesting talking about this. I know it's a huge issue and it's something that we deal with every day. So thanks so much for coming on and sharing wisdom with our podcast listeners.
It was fun. Thanks for having me.
So I'd like to thank everyone for listening to our podcast today. If you want more information about GCI Consultants, we've even got some videos and things like that on our website that show water leakage testing and whatnot. You can look that all up at www.gciconsultants. There's an S on the end of consultants. GCIconsultants.com. If you've got some specific problems that you want to talk about, you can reach us at 877-740-9990. Again, 877-740-9990. Thank you once again, everyone, and I look forward to talking with you next time on a future Everything Building Envelope podcast episode. This is Paul Beers with Jason Bondurant, signing off till next time. So long, everybody.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.